Hello and welcome. You may know that Azure AD evaluates conditional access every time there's an authentication event. But what triggers an authentication event? It could be when a user signs in. It could be when a cookie is used to prove authentication. Or a refresh token is used to refresh an access token. Or it could be when an API issues a claims challenge as part of continuous access evaluation. In this deep dive session, I will reveal these triggers. Don't forget to subscribe and keep learning. Come with me into the cloud. Okay, let's start by thinking about what is the core functionality of Azure AD. Its core purpose is to securely authenticate users and workloads against applications. And those applications could be cloud, software as a service apps, such as Office 365. They could be on-premise apps that are protected by sort of some hybrid secure access gateway, such as the Azure AD application proxy, or they could be third-party apps, partner apps, and so on. But the first thing that we need to arrange is for all of our users to be authenticated by Azure AD. And once we have our users authenticated by Azure AD, the next thing is we can trigger the conditional access policy engine. And that policy engine is going to make a decision as to whether we allow the user or the workload identity access to a particular application. And it takes into account a whole range of signals. Now, I'm not going to go into the details of those signals in this particular video. For those details, watch my Azure AD Conditional Access, the Gateway to Zero Trust video. So we've got signals coming from users and workloads, and then we've got also Microsoft's own threat intelligence signals that are coming in, so evaluating risk. And then we've got signals from devices that are coming in, and we might be using Intune. We might recognize the operating system that's being used and so on. Those signals are coming in, and we're going to make a decision as to whether we allow access to the application. We can enhance the signals with things like Microsoft Defender products, with using Intune for looking at the device and making sure the device is compliant. Next job, are we going to allow access? Well, we've got a number of things we can do. We could block access completely. We could ask for assurance to be increased by doing MFA. Or in certain circumstances, we could remediate. We could force a password reset onto a user. If we decide to allow access to an app, the next thing that can be done is we can apply session controls. And as I say, watch my other video to see all the details of this. This video is about deciding when conditional access is actually evaluated. And it's evaluated every time a request is made for a SAML token. And a SAML token could be got through SAML protocol or maybe even WS Federation protocol. Also, if you request an ID token, so that's OpenID Connect, or we request an access token using OAuth 2. All the times those tokens are requested, we evaluate conditional access. And there are also events that trigger conditional access evaluation. For instance, proving authentication by the use of a session token. We'll come back at that. Using a refresh token to obtain a new access token. Again, we'll look at that in a bit more detail. And also when an API rejects an access token through a claims challenge. And that's part of continuous access evaluation. We'll also look at that. But let's start by thinking about the authentication story. So we have a user that wants to gain access to an application. And what the application will do is say, you're not authenticated. Well, if they have been authenticated already, they'll, in terms of the user would pass a cookie to prove that authentication to the app. But assuming they haven't been authenticated, the app is going to redirect up to the security token service that it trusts, well, in this particular case, Azure AD. And we have a fairly complex string that we send to Azure AD, which is really saying, please authenticate the user to this application. And all of that information is held in the authentication request. Let's have a look at that in a demo. Let's start by going to an application, OIDC v2, and I'm going to sign into this app using OpenID Connect. Now, there we are up at Azure, and this is my string that I've sent. Now, I'm going to use Fiddler, and I'm just going to use the text wizard in Fiddler to convert that string and do a URL decode on it. It just makes it a little bit more readable. So let's grab that. And let's put that into Notepad. Now, I'm not going to go into all the details, but what I want to do is just sort of clean this up a little bit. So we'll break it down into its constituent parts. And I'm going to explain this in 1 second. But as I say, not the real detail. We'll have to do that in another video. So what it is, it's going up to a particular endpoint. That's the authorize endpoint. And it's by going there, it's saying, I'm doing OpenID Connect OAuth 2 protocol. And in this particular string, it's saying, please authenticate the user to this application. And after you've authenticated the user to this application, return back to this particular location. Okay, and there's things like response mode, the scope, and so on. And as I say, we'll have to look at that in another video. Let's go to a different application. Let's just close this off, and let's go off to a SAML application. And I'm going off to XCS SAML up here, and I'm going to go login. And that's going to send me up to Azure with a string. And if we drop that into Notepad, it's a rather different thing. And what we're going to the SAML endpoint with a SAML request, which is actually encoded. And I can grab that and pop that into Fiddler. And we'll go into Fiddler again, drop it in there. And what we'll discover is this is actually deflated SAML. So I'm going to decode it from deflated SAML. I'm going to grab that lot, and I'm going to pop that back into Notepad just to make it a little bit easier to understand. So again, I'm not going to go into the detail here. It will have to be in another video. But we're hitting the app. The app is saying you're not authenticated. And the app is making that decision because we're not passing a cookie to the app, and we're being sent off to Azure with an authentication string. It says authenticate the user to this application. And the protocol that is being used is the endpoint that we choose. So we want to speak SAML. We go to the SAML endpoint, which is here. And we can see that up in here as well. So that's where we're going, to the SAML endpoint, and we need to use the language that is appropriate for the SAML endpoint. And again, if we're doing OpenID Connect OAuth 2, we come up to this endpoint using the appropriate language to go there. When we log in, is MFA evaluated? Well, let's do something slightly different. Let's go to another application, and I'm going to go to my app OIDC v1. And I'm actually going to sign in this time. Again, we've got this string that's gone up, and I'm going to sign in as my user Don. And I've got the password sort of in the browser just to make my life easier. So we're signing in as Don, and it's saying, oh, you need to approve the sign-in request. And the reason we're doing that is because we've got multi-factor. So on my phone, I'm just putting in 82. I'm now signed in, and we can see it's Don Ovon, and the AMR, which is the authentication method reference claim, is set to password and MFA. Let's go across to the Entra portal and have a look at the conditional access policy. So here I am now in the Entra portal. I'm going to go to Azure Active Directory. Under Protect and Secure, I'm going to find Conditional Access. And if we look down through our conditional access policies, we've got this particular one down here, which is OIDC v1 MFA for all users when always. Okay, if we look at that, we can see it's all users. The one application that it's applying to is OIDC v1, and the grant, the control here is to grant access, we need to do multi-factor. So it was the fact that we were authenticating triggered conditional access evaluation. Okay, let's have a look at the authentication flow. Our user hits the application says you're not authenticated and sends the user up to Azure AD through a redirect. So we end up at Azure AD with this rather complex authentication string saying, please authenticate the user to app 1. The next thing that happens is that we have the authentication, whatever method that is in use, which would be executed. And if you watch my video on the authentication method policies, you can see there's an awful lot of different ways we can authenticate. Once we're authenticated, Azure AD returns a security token, and that security token is appropriate for the protocol. So if the protocol was SAML, that would be a SAML token. If the protocol was OpenID Connect, that would be an ID token. Azure AD also sets an authentication cookie, and that authentication cookie proves authentication to Azure AD. Next job is we go back to the application and we present the security token. The security token is proof of authentication of the user to the app. The app will then render back whatever page it needs to render back, having of course validated the token, and then it sets authentication cookies which prove that you're authenticated to the application. I feel the need for a little diagram on SSO. So let's go across to the Microsoft whiteboard. So we'll have our first application, which is app 1. And our user, right, hits application number 1 and is sent off up to Azure to actually get authenticated. And that's where we get authenticated. And after that authentication, Azure is going to return to us the security token, but it's also going to return back a cookie. And that cookie is going to be sent back, and we're going to store that cookie. Let's have it as a black cookie. We're going to store that black cookie down here. Now, when the user hits application number 2, go to app 2, again they're going to be redirected up to Azure. This time they're going to send that cookie up to Azure. So the black cookie up to Azure, and this will prove that the user is already authenticated. So every time we hit a different app, we're going to use the Azure cookie to prove that we've already been authenticated, and therefore it will be a single sign-on experience. Okay, so let's experience SSO in a demo. So I'm going to go to OIDC v2 and I'm signing in as my user Don. And that should be successful, which it is. Okay, now I'm not going to close the browser, we'll just minimize the browser. That cookie that we got from Azure is still inside the browser. And I'm going to go to my SAML application now, and I'm going to log in, and notice straight in, I am in there as Don. So Don has got into the SAML application through SSO. Now let's go against OIDC v1. Now remember, OIDC v1 requires MFA. We click on that and say sign in with OpenID Connect, and all we're being asked for is the second factor of authentication. I need to put in that value of 23, and now I'm in. It's given me an SSO experience. If need be, I have to step up my assurance by providing the second factor for authentication. Our next job is to look at access tokens and refresh tokens. But before we do, let's just set the scene with OpenID Connect and OAuth 2. OpenID Connect proves the user's authentication to the application, in this case, App 1. Now, App 1 can be given an access token which authorizes App 1 to access a backend API. And in our picture here, it's shown as App 2. So the ID token is proof of authentication of the user to App 1, and the access token is proof that App 1 is authorized to access App 2. Now, the access token could be using the user's identity, or it could actually be using the identity of application 1, in which case it would be a workload identity. Where do refresh tokens fit in with all this? If you know anything about continuous access evaluation, or CAE, I want you to forget about that for the moment. We have App 1, which has an access token which authorizes it to access a backend API with the identity of the user. Now, all these tokens have a finite lifetime. So what should the lifetime of an access token be? Well, if App 1 needs to continuously access App 2, even when the user's offline, that token lifetime has to be extremely long. Otherwise, when it expires, App 1 will no longer be able to access App 2. The challenge with having a very long lifetime for the access token is that App 1 has that token and can just keep going. There is no going back to Azure AD, and so Azure AD is saying, hang on a minute, I just want to check that you're still allowed that access token. So the design was to use a refresh token. So we have a fairly short lifetime for the access token. It's approximately 1 hour. And every hour, App 1 goes back to Azure using a refresh token and saying, hey, can I have a new access token, please? And at that point in time, Azure AD can do a check. So it can check, is the account still enabled? It can check if the password's been changed. It can check conditional access policy. So every 1 hour, by using this refresh token, we can go back and check whether we should be issuing a new access token. So I think it's time for a little demo of this. Okay, let's start off on OIDC v2. And I'm going to sign in with CodeFlow asking for an ID token. So I'm going to just update my scope and off we go. We're going to sign in as Don. And that's successful. I'm going to convert the code to token. I've got an ID token and I've got an access token. The audience with that GUID is actually graph. So if I look down there, I've also got a refresh token. So I'm going to click home on that. And what I'm going to do now is I'm going to use the refresh token. And what it will do is it will give me back a new ID token and an access token. And if I go over and look at the server itself, so if I bring my server up here, I'm running Fiddler on the server and I can see the interaction between the server. This is in my diagram App 1. The grant type is refresh token, and it's sending a refresh token back to Azure and saying, please give me a new access token. And in fact, it gets a new access token, it gets a new ID token, and it gets a new refresh token back. So that's the use of the refresh token, to refresh the access token, and in this case, the ID token as well. Now, let's go to our conditional access policy, and we're going to be using the Entra portal for this. And what I want to be doing is looking at SN14. So here, specified users included. And who are those users? Well, Don and John. The application is, I've got two applications, but one of them is OIDC v2. Right, and what's the grant type? The grant type is require multi-factor. So I'm going to turn that on, and I'm going to save that. Now, let's go back again to our client. So back to our Windows client, and I'm going to come back down here, and I'm going to go home, and I'm going to use the refresh token again. So refresh the access token, and it's failed, right? We haven't got one back. So let's go and have a look at what happened on the server. So we're over to the server, and we can see it's a bad request that's come back. We've got the refresh token, so everything sort of looks like it should be all right. But if we look in here in JSON, and I can grab the error description and I can put that into Notepad to make it a little bit easier. Let's just change the font size in here just to make it a little bit more readable. And what we can see is, if we put word wrap on as well, we can see that due to a configuration change made by administrator, or because you have moved to a new location, you must use multi-factor. So at this point, App 1 can no longer use that access token. A user has to be involved at this point. But the key here is I wanted to show you that when the refresh token is used, conditional access is re-evaluated. Let's just go back to our client, and let's just get the user involved. So I'm going to click home, and I'm going to sign in with CodeFlow again. And at this point, Don is being prompted to actually provide that second factor. Our last thing to look at is continuous access evaluation. And CAE is Microsoft's proprietary implementation of the core of continuous access evaluation protocol. CAEP is a work in progress by the Shared Signals Framework Working Group. In essence, is about an IDP as an identity provider being able to inform an API about a policy or about a significant event. Well, seeing as Microsoft own Azure AD, the IDP, and they own the API, SharePoint, Exchange, Graph, then Microsoft can implement what would have to become part of the protocol, and they can implement it today. So if we look at CAE, what we can actually see is that we've got Azure AD and we've got a Microsoft API. And Azure AD can inform the API about policy, and in particular network policy. It's saying, where the application is allowed to be in terms of IP address when it makes a connection to the API. The subscription, which will be part of the protocol with how we do that subscribing to events and policies, is inbuilt into the Microsoft ecosystem. So now our application comes along and it requests access to the API, and it passes an access token. At that point, the API can check the policy. Is the app coming from the right network? If it is, then we'll send back the information. But it can also check to see if it's had any significant event notifications, right? Such as the user's password has changed, the user's tokens have been revoked, the user has come into the scope of an Azure conditional access policy. If any of those happen, then what will happen is the API will deny access and return a claims challenge, at which point the application will go back to Azure presenting the claims challenge, and Azure will do whatever is necessary, maybe prompting for second factor, maybe blocking access, or maybe requesting the user to re-authenticate with their new password if the password has been changed. For this to work properly, the client has to be CAE aware. Otherwise, what could happen is the client could present the access token from cache. So it presents the access token's rejected, so it presents it again. It's rejected, so it presents it again. It could go around in a loop. So the application has to, number one, declare that it is CAE aware, and then that CAE will kick in when we're gaining access to this particular API. So it's initially focused on Exchange, Teams, and SharePoint. I'm going to show it to you with Microsoft Graph in a second. Critical events include things like the user account being deleted, being disabled, password change, password reset, MFA enabled for the user, refresh tokens revoked, and also an Azure AD identity protection detects an elevated user risk. That would cause this claims challenge to be presented. And in terms of CA policy, it's a network location change would cause, again, the claims challenge. Now, if you look at an access token, when CAE is disabled, the access token is about an hour in length. So we can see here it's issued at 16:16 and it expires at 17:21. Here, with CAE enabled, is issued at 19:05 and it expires at 2018. So you think, oh, what's the difference? But then you notice the day. It was issued on November the 28th. It's expiring on November the 29th. So we can have an access token which actually could have a lifetime of 28 hours, which means your app isn't continuously going back, oh, here's my refresh token, give me a new access token, and so on. So now, revocation of access is now event-driven and policy-driven, and it no longer relies on an attempt to renew the refresh token. Let's have a look at that in a demo. Okay, for this demo, I'm going to go to Graph using PowerShell. So I have the ISE running for PowerShell. I'm going to start up Fiddler, and I'm going to get it to monitor the command window for ISE. So now it's going to capture any traffic going from this particular command window. So my first job in here is actually to connect to MG Graph. So I'm going to connect up to MG Graph and I'm going to sign in as my user John at one.ad. And we're just going to go in with a password here. And that has now successfully connected me to Graph. So let me do one thing here, and I'm going to ask for information about myself. So I'm going to do a get MG user, but with my own identity. So run that selection, and that was successful. Let's have a look at Fiddler. So here is that call to Graph. And if we look at the headers in the call, what we can see down there is it's going to Graph and it's asking for the resource users John at one.ad.xtshub.com. If I look down here, I've got a access token. So I'm going to grab that token, and so I'm going to copy the value of that token, and I'm going to go to JSON-WebToken.ms. So JSON-WebToken.ms, and I'm going to drop that in there. So there's my token gone in. I just need to remove bearer from there. And if we look down here, what we can see is when it was issued and when it expires. Well, the nice thing about jwt.ms is that you can go to claims and it shows you the issued at was Friday, March 24th, 2023, 1512. And it expires on Saturday, March the 25th at 1517. So it has just over 24 hours as a lifetime. Now, what I want to do is go and make a significant change. But before I do, I want to show you where this particular application is declaring that it is CAE aware. And if we look at the first interaction up here, I'm going to grab this and I'm just going to drop it into the text wizard, and I'm going to URL decode it just to make it a little bit more readable, and I'm going to copy that and drop that into Notepad. Well, we had rather a lot of things in Notepad, and I'll bring it in here. And I'm not going to go through everything here, but I just want to pick this point out here. This is where the client is declaring that it is CAE aware. Okay, and that's why it got back this long lifetime for a token. Right, let's go over now to the portal. And what I want to do is go to users, and I'm going to go to all users and select my user John. So we just put John in here. And this particular user is John Williams. And what I'm going to do now is revoke sessions. And in a short while, it's not going to be instantaneous. We'll see that John's access is revoked to Graph. So let's go back to Graph, and through the magic of video, I'm going to actually just wait a period of time before I attempt to access again. Okay, so I just attempted to get MG user again, and it is prompting me to authenticate. So we can have a look at Fiddler and our last interaction with Graph, and what it's saying is 401 unauthorized. And if I think just look at the JSON in here, grab this lot and copy it and pop that into Notepad, and it's a continuous access evaluation resulted in a challenge. So we got a challenge coming back, and basically it's interaction required. So we have to get the user to sign in again. Thanks for watching this session to the end. I hope you enjoyed the level of technical detail. Now you know all about the triggers that cause conditional access to be evaluated. Don't forget to subscribe and keep learning. I'll see you next time in the cloud. Thanks for watching my channel. Subscribe for more free training. You might like to join me for my Identity Masterclass. Hopefully, see you soon.